All right, while you are getting logged into Desmos, right, because it shouldn't eat your mouth, we're going to collect homework on Monday because we're not moving forward today. I decided not to give you homework today. I know different people are stacked up on different things. I think most of us have gotten caught up and we're just waiting on some grades to be updated. So we are going to collect the first 3 homeworks from this chapter. So what we did this week, nothing from today. You can take 522 if you want. Like you can work on it over the weekend. But 511, 512, and 521 will be due on Monday. Now, you should have them done. Really, you should have it done today, but you should for sure have it done by Monday. I don't know if I'm going to get it in math on Monday or not. You guys got to stop with this whole like, but wow, like, it doesn't. I love you. I don't care. Like, get some academic grit. You should really be doing your homework tonight. It's assigned and have it done the next day. My 2-day policy is already pretty nice to you, of saying if you don't have time that night, like put it off to the next day, get it done the next day, it's okay. Next year, homework gets checked the day after it's assigned. You got to build some academic grit. So be ready to turn stuff in on Monday. If not, no whining. Okay, now 522 we won't be doing until Monday, so that'll be due like later, either end of that week or the following Monday, because we only have Monday, Tuesday that next week. Today, I was last night sitting there debating what we should do today, and I know Friday homework is kind of lame, so I decided we would do a Desmos activity instead. And to those of you that do not love Desmos, probably because it pushes you beyond the normal, just right or wrong, black or white, is this the right next step to do? Because Desmos makes you like predict things that you don't have enough information to know for sure yet. So it pushes you beyond your comfort zone. You don't know the code yet. Oh, you can just write Desmos activity if you want. Like you just want some paper out so you can jot down notes as you go. Si, senor. It's Puedo, if you want to be nice. May I go to the bathroom? Puedo ir al baño. Si. Muy pronto, por favor. Apparently this activity closed itself, so give me just a second. And by that I mean I accidentally closed the tab, I didn't mean to. Everyone should be on student.desmos.com waiting for a 6-digit code. Good. Unicorns flying freely. 7 purple gerbils. That doesn't, I don't know. Jackrabbits. Jackalopes.
7 jack-lanterns. Are you 7 pumpkins? It's Christmas.
Hey, you're not typing that in. I'm giving you mythical creatures because that's your code. Unicorns flying freely. As we've said before, I do not care what funny name you type in, as long as it's not inappropriate. Because we'd rather get to know some ancient mathematicians, like Brahmagupta, which is a famous mathematician. Brahmagupta.
I'm gonna do my usual. Who is this guy? Why do I do it?
All right. Your activity. Figure out where the dots are going to connect. There you go. That's it. Goodbye. You will once you start to collect data. You are not waiting for me. You are ready to go.
I'm waiting for the
First thing you're doing is placing your dot where you predict they will intercept. Yes, Hurricane Hazel? You're what? I am sorry. So we can see the comparison of where people are making their predictions. 100% confident. I want your confidence. I wish I was that confident on anything. Shoot, one of my favorite things is my doorbell camera because I can be confident that I shut the garage. I can pull up the camera and make sure the garage is closed.
Our garage door
Depends. You can see how they're moving. Hey, quit asking me questions. You got this. You know I'm not going to give you answers. You drive to that? You think you can figure it out? I wonder what the next slides are going to let you do.
So he's Albert Einstein. He's a physicist. But I'm Henry. I'm Henry. Whoever is Albert Einstein is very lucky to have him.
We're working independently. We will come back together and have a conversation about this as a class in a bit. Hey, gentlemen, I was literally just saying we are working individually. A lot of predictions are clustered around 40.
Yeah, that's exactly what I'm saying.
Oh, no, you can.
I'll turn on the fan. I do that. Oh, come on, Hudson. Set your coffee down and trip over the chair. Oh, we can't have nice things. For which? For red? So here's some experimental error. So the 10th of a second has. So you gotta decide what value. You just pick one of those values. 2.5 might work easy. I was picking for you, I'd probably say 0.5. And then that's coming in 0.5. So 0.5 is my fourth next step. What if we go to 1 second? I wonder if that's on purpose. You can't type in time. Just filter it in and see what it is. Ooh, 1 second. There you go. 5 and 23. That tells us something. That definitely tells us something. Do I need
That shows the 2.5 was good.
Is what we're figuring out how to do the job and put something correct. I'm sure it's not for something else, right?
It is.
Ooh, wow. Some good responses here. So if we come together for just a second, or it's not going to let me because the screen is still up. So check this out. Give me your attention up here real quick because, hey, I paused you. So I am going to keep this anonymized because I want safe space for mistakes and, you know, whatever else. Like, even if we just have not a great idea, like, that's not a mistake, but I might not have a good idea to share, right? So some of us might just say, like, use algebra or give me more info. Or some of us give really specific advice here. Like, find how fast both are moving. That's a great idea, but, like, if we scroll down here, check this out. While the blue travels 10, the red travels 20, and blue starts at 20, red starts at 10. That's a lot of info. That's pretty good. Put the dot at now, assuming assuming that what they typed is actually correct, right? So just scrolling through what people have contributed.
It's not completely anonymous. If you type in the name of a mathematician's name, it'll keep that.
Will it? That's funny. Okay, so I'm going to unpause you and let you keep going. We are trying to derive the exact location where they will meet. A famous mathematician. Now, I would encourage on the next screen, try it a couple times. As I look through these, I see some different values, and we're all operating on the same, like, dot engine, whatever you want to say, like the dots moving. We all have the same thing happening. So, like, I was just back working with Logan, and I think we got 2.5 at half a second. So I would say try them a couple times, because realize this only goes by tenths of seconds. There are still hundredths and thousandths, and like a tenth of a second is an amount of time, right? So the dot is still moving. You might want to do that a couple times and check exactly where it's at. You got 2.5 at one point, 0.5, 2.4. I would maybe use the numbers that are nicer. If you have the choice of, like, here it looks like somebody got 2.5, somebody got 2.4, I would maybe use the 2.5 just because it seems nicer. That's up to you. So 2.4 is not as nice. Zero seconds may not actually be there. No, I do not believe. So actually, guys, when you come to this screen, the first thing you really could have typed is 0, 0, and 20, right? Before you ever hit play. We could have hit 0, 0, and 20. Ooh. I'm really curious what.
If you click on it, you get that more specific
I
information.
know, but I don't know what the Y is. 3. Oh, they're both just 3 up from the line. That's why it says 3. That 3 doesn't mean anything. They're both 3 up from the line. Right? Because that line is 0.
They just do. That's just what it is.
I wonder if you could figure out how far each one goes, like every tenth of a second, or every second might be useful. Sorry, I'm not taking questions. If you have a question, you can like turn to a partner and ask. But I mean, we're all working through the same thing at the same time. By the way, if there's anyone who still feels like they need to work on the test, we can do that right now. So if you would like to put more time into the test, you feel like you haven't had enough, I do not think we have any AO time. We don't have any AO time today, so if you still wanted to put more time into your test, please come do that now. You can just take a pause on that activity. At least now, though, when we discuss it, you know what we're talking about. Anybody else want to spend some more time on your test? I'm grading them this weekend. I've not touched them yet. I like that noise. I dig it. I used to do that even at scout camp. It's just not what we're doing now. So, how could I calculate? I know there's only a few people still back on this screen. How could I calculate something that involves the word per? What operation do we do to satisfy the word per, Avi? Yeah, now it's not always a unit rate. You're right in this case, but when we use the word per, exactly what you said, we divide. Now if it's per 1, then it's the unit rate. So this is a unit rate here if we talk about 1 second. So if I take my 5.5 movement, divided by 1.1 second, that comes out to be 5. And 8.8 divided by 1.8 comes out to be 4.88888. So this is either 5 or 4.88888. Like, that's not a very nice number. So maybe this was meant to be slightly higher, and maybe this is actually 5. I don't know. Your data might agree, might disagree. How far did this move between 20 and 23.3? Just 3.3. Right? So be careful. That would be 3.3 divided by 1.1. Oh, and that looks like it's maybe a 3? Not really sure. Anyone do anything with this column?
Oh, yeah, I did that. I did that blue dot location minus 20.
Oh, so blue movement?
Yeah.
When you did 23.3 divided by 1.1, how'd you get 3?
It's not 23.3. So this is why Simon added this column in. So if we do that, the last column is the amount of blue move, because this column is already red move because it starts at 0. But blue did not move 20 in 0 seconds. It moved 0 in 0 seconds. It moved 3.3 in 1.1 seconds. It moved 5.3 in 1.8 seconds. Does that make sense? It's not 23.3. It's 3.3. So, who can talk about what red needs to do to make this happen? Hey, Bear. You know how easy it is to send a video to parents and be like, look, he melts in the middle of class. Don't know how to fix this. Henry?
The red dot needs to, it needs to, exceed the quantity of the blue dot at a given second.
Okay, and what does it have to do to make that happen?
It has to, wait until that, to sort of catch up to the blue dot.
How much catch-up does it have to do?
It has to do about 10 seconds of catch-up.
Come on, don't give me seconds. How much, like when we start, how much does red have to catch up? 20. So what we're saying here is red needs to move an extra 20 compared to blue in order to catch up. That's what Henry's saying is red needs to catch up. It needs to move an extra 20 to do so. Keep working, see what you guys can figure out. So we look at what other people are trying to do. Actually, I'm curious back here. 50, 50, 65, 55, 50. This is really immature. Don't care who you are. You don't need to tell us, but that's really useless. 50, they'll meet 10 seconds. We got a lot of 50s. Looks like 50 is everybody's favorite guess. Now wait, if I went back here though, most of us were guessing right around 40.
Somebody gets right on the dot.
Yeah, somebody's out here. Don't know. So then, Amelia said, I found the unit rate, or how fast each dot. I used absolute values. I used the unit rate. Stopped every couple seconds, recorded the data. Ooh. Rates and simultaneous multiplication. Drew a model of it. Everyone open a new tab. No, I'm not serious. I just paused you to be not serious. Yes, seriously. Go to Desmos.com. Not student.desmos.com, just Desmos.com. Hit start graphing. I want to teach you about something that you don't have to be in an activity of mind to use. Who's actually doing Phoenix Fair that can give me some information about your Phoenix Fair right now? Liam, what are you doing?
Me and Bear are working together, and we're making brownies and bread.
How much is all of that going to cost you?
I have no idea.
Give me a ballpark. Or, okay, does somebody have data they can give me? Like, Simon, do you have numbers?
Yep.
We'll wait for you. If you're pulling something out with data, I will so wait.
$16.99. That's what I have directly.
Everybody right now, think about what your Phoenix Fair is hypothetically going to cost you. Type in y equals, and then make that a negative. What? Things don't cost zero. Simon, what's yours going to cost?
$35.53.
Simon is going to spend $35.53 on his project. But then, Simon, what do you plan to sell each? What are you doing? What are you making?
I am making a special drink, and it costs $3.
$3 each. So Simon has spent $35.53, and whatever you have typed in here, it should be negative. He's going to make $3 or $3.50. Did you say?
100. Wait, what?
$3. What are you charging for each drink? Just $3.
Yeah.
He's gonna make $3 for every drink he sells. That's X. Give me your eyes up here. This graph is showing the Y amount of money Simon has. If Simon is very unsuccessful and sells no beverages, he ends up in the hole $35.53. In order for him to break even and just be able to pay back his parents, how many does he need to sell?
About 11 or 12.
Is 11 enough?
No, you need 12.
Simon needs to sell 12. Because what we're talking about when we graph things, when we use linear equations, is realistic situations. So with this red graph, go ahead and delete what we just typed. Where did our red dot start? 0, right? What did we say it moves by? How much did it move every second? 5, right? Every second. Where did blue dot start?
20. And it went by 3.
And it went by 3 every second. And when I unpause the Desmos activity, if you haven't made it there, you will see it. But check it. In Desmos.com, you're not in an activity of mine. You're just graphing on your own. I can set up both of these graphs and check it out. Point of intersection. It takes 10 seconds, and they meet at 50. The purpose of Desmos.com. Just give me your eyes real quick, because if I haven't talked about this, it's really cool, and I want you to start using it whenever you need to. Their objective when they set out and they started making this website was to be able to tell you and any students, you don't have to or need to buy this. This is a $150 calculator that does a lot of stuff. Saves you a lot of time and a lot of effort. This website does it all. For free. Not necessarily faster. This is actually better at certain things. But Desmos.com is trying to replace the graphing calculator, and it's free. So, especially if you don't have one of these yet, that's fine. As we start to graph things, if you want to play with like linear graphs and stuff like that, go to Desmos.com and graph things. You have a bajillion options here. You can also, if you're one of my curious kids and like the art side of things, can look down in the website and see what other people have graphed. And you can also talk with Logan, who has dug deep into Desmos and has hit some of his own graphs that he's made. Yes, but people will graph things like BoJack Horseman. And if you want to be able to graph a BoJack Horseman, you need a lot of equations.
Wow.
These are all of the equations that they used. These are domain restrictions or range restrictions. So in the fancy brackets, you're either restricting the y or you're restricting, you're either restricting x or restricting y. And then I can turn on or off the equations to see what it does. So that is this little piece. Now, to make these graphs, they actually overlaid a picture, right? So they would have plugged in a picture of BoJack Horseman, and then they would have created all the graph pieces, and then they deleted the picture. So back here, I will unpause you. We have approximately 5 minutes left. If you would like to go ahead and put your Chromebook away, you may, and you can work on homework. Or you can play in Desmos, like you can look at the mat art, stack picks, you can do whatever you want. You got 5 minutes. So that's one of the cool things about Desmos. If we go into here, notice it has circles involved. Click on the arrow, it drops down. All circles are in this form. But if we want to like back ourselves up and make an easier one, and this is where like starting to play with it, x plus 2 squared, watch, y plus 3, let's say, so that Alex can actually figure out what's happening here, equals 9. Nope.
Wait, how did you square it on the computer?
Yeah, it's because I'm recording. If you want to put in a square, you hold shift and you hit 6. It's the upper caret.
Oh, yeah.
Or look up here. Click this little keyboard.
During period 2B.
That little keyboard has all these options.
To the family room for science. 8th grade science for 2B, please report directly to the family room for science. Thank you.
How do you see all those other fancy graphs?
Just go to Desmos.com and scroll down. Scroll down on the page, and it gives you different options. Those are the math art things. You'd have to log into your Desmos, but hang on for just a second. Well, to show it up here, like you'd have to log in up here. So hold on, we're trying to derive stuff. So this is one of those situations, Logan, where you know more than the rest of the class. You got to let me teach to them for a minute, right? So maybe, hey, Logan, can you and I actually plan when you can share some Desmos stuff? Because I want to give you more than 2 minutes. And right now, all I would be able to give you is 2 minutes.
All I wanted to do is just show you on here.
Yeah, give me a second and I'll come look at your stuff. I want you to show the class. Alex, work this with me. We typed in an x with a positive 2, a y with a positive 3, but when I come down here and I look at this circle, where's the center of the circle?
It's going to be in -2,
negative 2, negative 3. And then in Desmos, wait, I have a hypothesis. Let me test this hypothesis. If I change the x to 4, wait, if I change the y to, I don't know, what if I make it a negative actually?
How would you make the circle smaller?
Ooh.
Wait, how small can you make the circle?
Can anyone figure out what's happened here? I will formalize it. I will tell you, but I am curious if you were able to figure it out this quickly. Logan, do you actually know? Logan, do you know it? What the actual equation is? But do you know what's happening here? It's totally okay if you don't. I'm just curious. I should, in the true teacher fashion, I shouldn't tell you this. I shouldn't give it to you yet, but I'm going to. Because then it would make you curious and hopefully you would go explore. Yeah, that's why I'm saying I shouldn't give this to you, but I am going to at least draw some things out here.
I thought it was the job of the teacher to help us learn what they Wait, is it the circumference?
What is the center of the blue circle?
It adds a negative to it.
Except I don't understand that.
It adds a negative to both of them.
Mark, the only thing that I'm confused about is how is it negative?
I have a question.
The only thing I understand
Is there some way to make a graph that goes like that? Goes like what?
I'm not going to give you anything else. We are out of time.
Wait, where's the squiggly graph?
Family room. Then you should listen to announcements because I don't. They never change what I'm going to do because I teach whoever shows up. Sorry, if there was an announcement, I did not listen. Okay, do you understand what's happening in this? The base function. Could you explain to me how this turns into a circle? Like what I do with the values in the parentheses or the C. What is A, B, and C? But what's happening is C. It's not times 5. Or what? Were you here the day that you did it? I think it's the drawer right beside chessboards for you guys. I'm not going to tell you today. I would tell you if you were right, but you need to go to your next class. Actually, you just made it that it's impossible. It can't graph it though. It can't graph it because it's impossible. What you typed in is able to be typed in, but it's not possible. Math 7! These are your directions.